Hi guys, we've been talking about resistance for a couple of days now. Every wire that's ever been created has some resistance. Wires come in lots of different flavors. I got tiny little wires, I got somewhat thicker wires, and I got much thicker wires. And they come in 1,000 different varieties and flavors and such. And each one has some resistance associated with it. If you think about it, an electron, we stick it in the end of one of these wires, and it kind of bounces around and the other electrons kind of get out of its way, or actually it is the ripple effect of the electrons bumping into each other that causes the electron to slow down, and that is what we measure as resistance. It turns out we can measure resistance for a given piece of wire. If I have a wire that is, say, that long, there will be three things that go into determining what the resistance in that wire is. The resistance is proportional to the length. The longer the wire, the more resistance it's going to have. When Mr. Ohmsted first did these experiments, he started with a little piece of wire and measured its resistance, and then he doubled it and tripled it and quadrupled it, and eventually was able to figure out Ohm's law, which we've discussed before. But the longer a wire is, the more resistance it's going to have. Resistance is inversely proportional to the area being the end of the wire, how big in diameter, or how big an area, obviously that would depend on the diameter, the wire is. Think about it this way. The bigger the wire is, the more that electron can work through there. It has lots and lots of atoms to run into and lots of other electrons that it can trade places with. So if you want to reduce the resistance in a wire, one easy way to do it is to make the wire bigger. That's why extension cords are fairly fat, and the little cord coming out of your lamp is fairly small, not big around. The extension cord has a long ways to go, and therefore it's got to have some pretty low resistance. The other thing, the thing that might sneak up on you, is resistance is dependent upon the material. We can use anything that conducts electricity. It could be copper or aluminum or gold or silver, anything that conducts electricity. And if we look at the atom itself, it's got its nucleus here and it's got several shells of electrons. Well, depending on how many electrons are in the outermost shell and how tightly it's held, how much the electrical attraction is, it would be easier or tougher for a given atom to lose an electron if that atom was of, say, copper or aluminum or silver. So we measure something called resistivity. That is a measure of the element. Now, you don't calculate resistivity. We did some experimentation and figured out what resistivity was. And there are charts in both the CPA book and the AP book that talk about the resistivity for certain particular metals, and I wrote down a couple of them. Lead, the resistivity is 22 times 10 to the minus 8. For iron, it's 9.71 times 10 to the minus 8. And copper, which we tend to use a lot of copper in wires, copper is 1.68 times 10 to the minus 8. That is a measure of how easily an electron can move through that particular material. So if you were going to work out one of these problems, you'd have to look up the resistivity in a chart, or I would give it to you in the problem. When we put all this together, there is a formula so that we can determine the resistance of a given wire. The formula is the resistance is equal to the resistivity, that material that I said you had to measure, times the length of the wire, how long it is, divided by the area of the wire. That is all from, as we put together what the previous page said. If I write it in symbols, resistance is equal to, that is a Greek letter, looks like a P, it's a rho, it's kind of a cursive P. That is resistivity, L is length, and A is area. That's pretty much all there is to figuring out the resistance of a given length of wire, of a given diameter, of a given material. I will say that resistance is measured in ohms, and since length is meters and area is meters squared, that would mean that the units over here, since the units over on the left side are equal to ohms, they have to be equal to ohms on the right side. So resistivity is measured in ohms times meters. Ohms times meters divided by meters squared leaves you with just ohms, which is what you want. How about we do a sample problem? I'm glad you asked. A current of 1.2 amps flows through a copper wire that is 1.75 meters long and has a diameter of 1.1 millimeters. What is the potential difference between the ends of the wire? Well, the first thing I got to do is I got to figure out the resistance of that wire. I know how long it is, somewhere 1.75 meters. I know its diameter, and from that I can figure out the area of the end of the wire, just that, whatever that little circle-like thing is. And again, from our formula, I would have to know the resistivity, but I know it's copper, and I looked up in a book, and I see that the resistivity for copper is 1.68 times 10 to the minus 8. Let's plug it all in the formula and see where we get. Now, that's not going to give us, it asks for the potential difference between the two ends of wires. That's the first step. The first step is figuring out resistance. Once we know resistance, it tells us current, and it asks for voltage. We neither know nor care about power. That means we use Ohm's law, V equals IR. We'll plug that in as soon as we find resistance. There's our formula. Resistance is rho, resistivity, times length divided by area. I plugged in resistivity. That's what I looked up in the chart, 1.68 times 10 to the minus 8 ohm meters. This is length, 1.75 meters long. Area, the area of a circle is 2 pi r. So it said the diameter was 1.1 millimeters. I converted that into meters. It'd be 1.1 times 10 to the minus 2. And then I divided that by 2, so I got 5.5 times 10 to the minus 3, and that is squared, pi r squared. So I worked all this math out, and I came out to the resistance was 0.31 ohms. That's the resistance in a piece of wire that's 1.75 meters long. By the way, we're going to do a very similar to this experiment here in a couple of days. So now, it asked me about the voltage. It said that the current going down it was 1.82 amps, and I calculated the resistance as 0.31 ohms. So I plug it into Ohm's law. 1.82 amps times 0.31 ohms is 0.56 volts. The difference, if I put a voltmeter up to the ends of that, it would read 0.056 volts. Potential difference between end A and end B, the end the electrons were entering and the end they were exiting. That's all there is to figuring out resistance